welcome back. You are not going to be able to see me today. I'm a little under the weather, and I know I use my hands a lot when I teach. But to stick with my teaching schedule, I had to make sure I still made this video, even though I'm not 100%. So just, nothing's wrong if you can't see me. That was actually on purpose. Let's finish off this week with cross-cutting concerns and error handling strategies. So we've been talking a lot about alternatives to inheritance, dependency injection, and now we're going to talk about when we have code that sort of is required throughout the space, throughout our code base, and how we can handle that. And it is absolutely going to be more conversations around composition and dependency injection. So what actually does the term cross-cutting concerns mean? And effectively, it's going to be code that weaves itself into everything. So it's logic or functionality that ends up affecting multiple parts of our system, often repeated across modules if it's not being handled centrally. So this is similar to examples we've seen where we have the same type of validation happening in multiple places, or perhaps similar types of logging functionality that happens in multiple places. So since we're not handling it centrally, we find ourselves copy pasting and repeating code. So some examples of this include logging, as I said, authentication and authorization. So role-based security and making sure that things actually are an appropriately permissible user is logged in and can access certain pages. So sometimes we need role-based security on multiple pages. Input validation, as I said, error handling and recovery. So the recovery situation may be similar for a lot of pages, even if the error messages are different. Performance monitoring, and string literals and constants. And of course, string literals and constants is a huge one and one that I see all the time in these projects. So the problem is we do end up with the same logic repeated across many different classes. And when we start to mix our business logic with some unrelated concerns, we end up with everything all tangled together. So that might mean lots of string literals being sort of placed everywhere, or logging being, mixed in with our logic, our actual code logic. So there are two main approaches to dealing with this. We have interceptors and we have middle layers. So before we actually talk about these two options, we have to understand what is actually supposed to happen where. Now that we're a little bit further into our projects than we were when we first talked about the layering structure, this is a good chance for us to sort of just revisit the diagram that we would have drawn and what each layer is responsible for. So the UI or the presentation layer, its job is to catch things, right? It's supposed to be in charge of catching and displaying friendly messages. Now, depending on how far along you are in your project, this might literally just mean its only job is to show things, to try to run code, catch the exceptions thrown, and display friendly error messages. The business logic or the logic layer, its job is to transform or wrap the domain-specific errors. So when errors come from the database or from specific scenarios, its job is to help sort of mold that error message, that exceptional message, into something that will work for the front end. And then the database or the persistence layer, its job is to actually catch those low-level issues and throw database-specific errors. So here we are just talking about sort of in general, how we want to handle error messages and who's responsible for what, so that we can sort of figure out what structure we need when it comes to these cross-cutting concerns like error handling. So here we can see that the UI layer, its job is to send data requests to the business layer, and its job is to catch exceptions, while the business layer is supposed to send data to the UI layer and throw some UI-friendly exceptions. So its job is to take error messages and make them UI-friendly and pass them to the front end. Now, the business layer also is responsible for requesting data from the database or the persistence layer. And it can pass. It's basically the pass-through layer in that sense, right? It is getting the data from the database layer so that the UI layer can use it. And it's responsible for catching any exceptions that the database layer throws so that it can be, as I said, wrapped or transformed into domain-specific errors. Lastly, we have the database layer, and its job is to connect to the database and retrieve data stored. And then it should be returning that data to the database layer. So it's not actually requesting anything from, oh, sorry, returning to the business layer. So it's not actually requesting anything from the business layer. Its job is to return sort of respond to the requests it gets. Or it can catch really low level exceptions, meaning like database connection, file not found, IO exception, like Java low level exceptions are caught at this level. And then it can throw a more specific or custom exception up to the business layer. So with that in mind, let's look at this idea of a shared utility or a service class, or potentially multiple of these, as one of our main approaches to handling these cross-cutting concerns. So all of these cross-cutting concerns could then be centralized into shared classes, like a logging class, a validation class, an authorization or security class, right? We can make this reusable across multiple modules. Like we can have a logger service, an auth service, a validation service. These can become their own package as like a utility package. So it doesn't actually live within one of our three main layers because it's cross-cutting. All of the different layers need access to this information. Pros and cons with that. There's lots of pros. We do get that reusability. We do get the consistency. However, we also could be exposing pieces of our code to the client side, to the middleware side, right, to the database side that maybe it doesn't need, because maybe the front end needs the logger service, but not the author validation, right? Or maybe the database needs the logger and validation, but not the auth. So if we put it all in one package, we're suddenly exposing all of this code to possible components of our project that it doesn't need access to. The other option, as I said, was interceptors or middleware. And this is code that basically runs before or after the main logic, and it would happen automatically. So there are some common frameworks that exist. There are some frameworks where this is already common, I should say, right? So we have servlet filters, Spring interceptors, express middleware. So basically every request that passes through the logging or auth layers before they reach controllers. So in some frameworks, this is like the default where you can set up your own logging and auth, and by default, everything will pass through them to ensure consistency and reliability. So interceptors by name are intercepting those requests to ensure that everything is getting logged and authorized appropriately beforehand. These aren't as common in our projects, but it is a way to handle these cross-cutting logic and cross-cutting concerns. What we see much more frequently is the shared utility or service classes. Now, in either case, when we're trying to figure out how to set this up, we've already mentioned the strategy pattern, but let's bring it up again because that's exactly how we want to structure our code to be able to handle these concerns. We want to use the strategy pattern for swapping behaviors like logging and validation without ever having to actually change our core logic. So we could have like a logger interface, and then we can have file loggers, database loggers, and console loggers, right? So we can have one type of logger that's in charge of the behaviors associated with that layer while still linking them all as different types of loggers. So here's a mini example of an interceptor. We have that interface log, and we have the two different loggers here. We have a file logger and a console logger. So we can write to a file or write to a console. If we're debugging, we can write to our console and it's helpful. If we're not debugging, a file logger would be more helpful so that we can sort of access everything after the code is finished completing, right? So instead of sprinkling logic methods and information throughout the program, putting like print stack traces everywhere, system.out.println, all that good stuff, we can make our own classes that contain the behavior, and we can just force all of our code to pass through them as part of processing, right? And this keeps our layers clean. So within the order processors and the email processors and the user process managers, we can force this behavior. Now, when it comes to centralized error handling, we have some best practices here. We want to have one place that can catch the errors, log them, and then respond. So we may want to be logging more than just error messages, hence these sort of different loggers and the ability to use them in like the processor like classes. But in addition to that, you might want to also be logging your exceptions, right? And this can all be handled at some kind of top level boundary. So in your controller, in your service manager, in your request handler, whatever it is, you want to make sure that you're doing it consistently in one place. So if you're going to be having something throw an error, then anytime we have a catch, maybe that's where we want to do our logging. If we're going to log front end errors in the controller, we need to make sure that all controllers are handling errors in that same way. So we really want to enforce that consistency, and we want to document it as well. When it comes to like a more distributed system, maybe in the future, a more complex system, we want to make sure we're always returning useful, safe responses to the caller. So right now, we often, like in this project, we rely quite heavily on exceptions and throwing exceptions over like returning a true or false. But in the real world, we sort of rely on status codes a little bit more, like an integer status code on whether or not things went well or something broke, whether or not things are responsive or not, stuff like that. We just want to make sure that we're always returning safe responses. So if a user can't be found, rather than returning null, perhaps we're returning a dummy user. Or if somebody does a search and it returns no results, instead of returning null, we should be returning an empty list. So we really want to make sure that we're making smart, safe choices in how these scenarios play out. Now, we do use catch a little bit throughout our layers, we'll say, but we don't really want to catch all of the exceptions everywhere, because if we just catch it, we basically will find ourselves catching and ignoring problems. And this hides the problems. We don't know why our code is non-responsive. We didn't log an error to the front end or to the console, right? We have no idea. And when we have these try catch blocks kind of scattered throughout our code, we find ourselves with duplicate code and inconsistencies, and that can make debugging a lot harder. So if we decide our front end is going to be responsible for all of the catching and logging for our project, just given the type of project that it is, that's a really good idea. The catches can effectively, like every other method could basically throw exceptions. So the database throws exceptions, everything in the logic layer can throw exceptions, and everything just sort of passes through up to that top layer. And then we can have controllers in our UI layer that's responsible for the actual catches, the logging, the displaying, however we want to handle that. Not all processes might work this way, but there's nothing wrong with us setting it up like that. If instead you want to handle it in the logic layer, you can. The only problem is we do run into sort of duplicate logic where the front end now needs to figure out whether or not an exception was thrown and how they want to sort of fail gracefully for the client, like for your customer to see, for the user. So typically, like my general rule of thumb has always been to pass everything to the front end. The front end, basically all of the UIs are just wrapped in try catches. And everything else is just throws all the way through. And that tends to work reasonably well. If there are some low-level potential throws in the database, those can catch, and then they throw a more specific exception. So like maybe they catch a database connection error of some kind, and then the function could throw a custom exception of like user database not connected, so that we know where it's coming from. So we do actually see a little bit of catches even when we're trying to propagate forward, but it's very minimal. So here we can sort of see an idea of what scattered logging might look like. So in our process order method, this would be like in our service layer, in our logic layer, we might remember to add the logging, but we also might not. Those are things that we may or may not remember to do. We also may have to keep a logger object in the process, like in the service layer and in the front end. Like we have to keep multiples, which might be unnecessary and inconsistent. And so frequently I see this e.print stack trace, right? This is us thinking we're logging to console, but without a dedicated logger doing it in the way that we want it to, whether it's going to console, going to a file, going to a database table, this just gets swallowed a lot of the time, right? We can't actually see it. The front end has no idea what happened. Now over here we have a logger class. A request comes in, it tries to get processed, and if an exception gets thrown within process, within get order, and at any point sort of in that try, This catch, while it does say exception E, we don't want to do that. This is just showing a generic example because it's a generic handle request. We never want to catch capital E exception, just like I wish I could like block that out now. Point is, we're going to catch it. We're going to catch all of them in this handle request function. We can log all of our errors appropriately, and we can send the error response elsewhere as needed. So when it comes to trying to get the errors propagating upward, when do we actually do our throws? Well, we want to make sure that we're validating our inputs as soon as possible. In this project, we try not to validate in our UI package because UI is responsible just for display. So within your logic layer, you should be validating your inputs as soon as possible, ideally in the constructors of things if possible. But again, we have some restrictions in this project, like making anemic models. So our constructors are just setting a bunch of stuff. Or, we can do it though in our logic layer as soon as things come in. So if we have a function for processing data, we can do our validation before we move further down our processing. Right? We want to avoid letting bad data flow too deep into the system because it becomes much harder for us to trace. Our stack trace gets longer, things get more complicated and messier. We want really clear messaging. We want to make sure that we're using specific exception types to indicate what went wrong. So like I said, it might mean catching an exception from the database and then throwing a custom exception so that we know exactly what table it came from, what happened, what we know, right? We want to try to include helpful, actionable messages. And we really want to avoid the generic, something went wrong, contact an administrator, or swallowing exceptions. Now, I'm not saying never use those because, of course, at the front end, they don't need to know what happened in the database. In fact, that could be considered a security risk. If we tell them what happened in the database and it's somebody trying to do harm to our database, we're giving them more information than we want to. So sometimes our front end does say, something went wrong, you need to contact an administrator. None of your changes will be saved or whatever. Because we're avoiding giving any specific indication as to what went wrong. But that doesn't mean we can't log what went wrong somewhere secure, like a database logging table, like to a file that we can access later, or if we're running in a development environment, a local environment, to console. So here we can see that we're doing our process order. We have a new order. We have a bunch of logic. If the order get items is empty, we're throwing a runtime exception saying error. This is bad for so many reasons. First of all, if we try to get a bunch of orders and it's empty, is that really an error? Or are there just no orders to display right now? Right? So maybe we just need to return an empty list and just say, there were no orders to return. It's not an error. That's not really an error. So we really have to ask ourselves, is this an exceptional scenario or is this something that's perfectly reasonable and could happen, right? Then we also see that we're throwing a new runtime exception that just says error. Runtime exception is too general. I don't want to see, or as much as possible, we don't want to see the throwing of built-in Java exceptions, because instead you should be throwing custom exceptions that you've created that land under the helm of a runtime exception. Like it can be, it can extend that or extend throwable or implement throwable, pardon me. Lastly, super nondescript. We've lost any sort of helpful tracing with this. We don't have any information as to why this random runtime exception was thrown except for the word error. Again, it's not even really an error, so this is just all around not really well done. Here is that code, but written a bit better. So again, if here we can see we have order get items dot is empty, and given this error message, I can actually now see why this is throwing an exception. Here it looked like they were trying to process an order. They were trying to get the list of items in the order, and if it was empty, we would just be like, oh, you don't have any orders right now. So in my head, it was like you were trying to get the list of orders, which is clearly not what this is. This is getting items, but there wasn't enough information here for me to see that. Now here I can say, oh, if order.getItems is empty, throw new invalid order exception. So we have a custom runtime exception. The order must contain at least one item. This is enough information for me to now understand what the problem was with this. We tried to process an order. Somebody tried to check out their shopping cart with no items in it. We can't do that. That's not a thing. Now, maybe we shouldn't allow them to push submit if the, cart is empty. But if we're trying to stick with this idea of we're not putting too much, we're not putting too much logic in our front end. We allow them to push submit even though their cart is empty. And now we can just sort of tell them, hey, this order is not valid. You can't be sending me an empty order. Way more descriptive. So we really want to sort of maintain the resilience that we have in our code through these error boundaries. We want to isolate risky code so that any failures that do occur will not propagate through our code unchecked. And just because one module might fail, the whole system shouldn't be brought down. So it brings us back to this idea of failing gracefully. We want to make sure we're wrapping unstable calls with protective boundaries. So for example, if you're going to call a third-party API to get shipping rates, right? Let's say in my app, I'm selling products and I'm going to pull in the UPS shipping rate, the Canada Post shipping rate, and the FedEx shipping rate, and then that way the user can choose which one they need, so or which one they want to go with. So I have to use their third-party API. If the API fails or it returns bad data, my whole project does not need to fail. Maybe I just don't show that option. Maybe I say you have to contact that company for their information. Maybe I don't I hide any information I'm unable to get, or I can put a number, like a cached value that I've used previously with a note that says this number may be an estimate, right? Like there's different ways to handle API calls failing without the whole app crashing or basically telling somebody they can't use our product anymore. Right? If we didn't have any boundaries, the raw exceptions just crash the whole order. But with boundaries, we can throw an internal exception that we choose how we want to handle, such as not displaying that line, telling them a general estimate, whatever it might be. So this is kind of what that might look like. We can see here that we'd have our shipping API wrapper class that we would create. We would call, like the front end would ask for the different shipping rates, right? So it'd pass it an address and we'd say, get the rate to ship to that place. We would try to call through our API to get the rate for that address. And if the API throws some kind of exception, whatever it is, this will be documented in API documentation, right? It will tell us what get rate might return or might throw. We can catch it and we can throw our own sort of custom descriptor here. So shipping service unavailable exception. So that service just isn't available right now, could not retrieve the shipping rate. It doesn't really say why. We could include more information, but again, we want to sort of balance not including too much information about the APIs that we're using to avoid sort of giving more information than we want to out to users who may want to do us harm. So some of those error messages were great and some might be a little bit too technical. And it's really important we remember that while we're trying to make a cohesive code base where everything works together, what is considered a friendly front end message is very different than a back end message. What a developer needs to solve the problem looks very different than what a user needs to solve the problem. So I found some sort of different screenshots from sites that I've used in the past or on Reddit. People post these all the time of just like not so user-friendly error messages. So here we can see somebody went to go try to change their password. They're changing it to something that apparently is weak, but that's on them. And when they tried to hit set, it looks like it says you must wait longer to change your password. That's nonsense, right? What does this even mean? I have no idea what makes a strong versus weak password here. I have no idea when I'm going to be allowed to come back to this screen and try to change my password again. This is not a helpful error message at all for our users, right? We want to make our product as intuitive as possible. And then one of my favorites, your microphone null is not working. Please go to settings to try a different one, right? This is so not helpful. This user messaging is not clear. It should be clear and actionable. I should know what I need to do. Like as a user, I should know what I need to investigate or restart or who to contact. So we really want to make sure that even though our backend messaging might have words like null in it, those aren't propagating their way forward. We really want to try and find that balance between too technical and exposing details, but also we don't want to be too helpful because that also might expose details. We talk more about that in other courses as well, like this idea of too helpful. But if somebody types in their credentials incorrectly, most websites will say either your email or password is incorrect. They don't tell you which one, and they do that on purpose, because there are people out there who would attempt to type in the password and recognize, oh, well, we found an email that's on this website. We just don't have the right password for that email, or somehow vice versa. Doesn't really make sense in the opposite way, but whatever. So we really want to find that balance between overly helpful and overly technical when we're showing messages to the users. So if you haven't done so yet, this is a really good time to pause and reflect and add a validation or error layer to a part of your code base. This might be like a standalone layer, or it might be a sublayer within one of your packages, and both are okay. It just sort of depends on your needs, right? Make sure that you're storing the messaging that you intend to use with your error layer in a central location, which means a file literally called stringconstants.java or whatever. Normally you'd use a config file, like maybe an XML or something, or a JSON file, but we don't have to get that complex. I just want to, see some kind of consistency. So it is some kind of like static constants file. That will allow these error messages to be more easily reused in other places in our code should we require them. So sit down by yourself with your group, however you want to take this, and take some time to plan out what kind of error validation, like wording you might need, where does it make the most sense to live, and go ahead and try to implement it. With that, we're finished with the week 6 material. We discussed dependency injection. We discussed inheritance, or composition over inheritance. And then we discussed how we can use things like composition to add loggers to our classes, or even honestly just injecting those loggers in to allow for different types of loggers depending on the environment that we're running our code in. And then that sort of led us into this discussion around what makes a good error message and how do we set all that up, right? Hopefully, we're going to start to see some really clean error messages in all of our projects. Have a great rest of your day, and I'll see you in next week's videos. Bye.